Greetings, welcome to this new video about nodal analysis or node voltage method. Solve the problem number 1. In this video, I will demonstrate how effectively solve a problem using the nodal analysis method, and I will guide you through the step-by-step process, ensuring a clear understanding of each stage. Let's consider this network consisting of 3 resistors labeled R1 through R3, as well as 2 independent current sources IA and IB. The question now is to calculate the voltage values at the nodes. Let's move on to the solution. First, let's start by labeling all the nodes in the circuits, and I will consider this node as node 1 and this node as node 2. After, we will assign the voltages V1 and V2 respectively to those two nodes. Next, we need to select a reference node in the circuits. The reference node is typically chosen as the node with the most connections, or as the ground node. Now, let's assign arbitrarily the currents in each branch, and I will consider I1 is the current through the resistor R1, and I2 is the current through the resistor R2, and I3 is the current through the resistor R3. Next, we will proceed to apply Kirchhoff's current law in each node. Let's start first with the node 1. By applying Kirchhoff's current law at node 1, we can write IA is equal to I1 plus I2. And if we replace IA with its numerical value, we obtain I1 plus I2 is equal to 14. Let's move on now to node 2. By applying Kirchhoff's current law at node 2, we can write I2 is equal to I3 plus IB. And if we replace IB with its numerical value, we obtain I2 is equal to I3 plus 7. According to Ohm's law, the currents can be expressed as the voltage difference across a resistor divided by the resistance. This implies that the currents can be determined by the following equations, which I1 is equal to V1 minus 0 over R1, I2 is equal to V1 minus V2 over R2, and I3 is equal to V2 minus 0 over R3. Now, by substituting equation A and B in 1, we can write 14 is equal to V1 over R1 plus V1 minus V2 over R2. And if we replace the resistors with their numerical values, we obtain 14 is equal to V1 over 4 plus V1 minus V2 over 5. And if we combine all the terms of this equation into a single denominator, we obtain finally 9V1 minus 4V2 minus 280 is equal to 0. And now, by substituting equation B and C in 2, we can write V1 minus V2 over R2 is equal to V2 over R3 plus 7. And if we replace the resistors with their numerical values, we obtain V1 minus V2 over 5 is equal to V2 over 5 plus 7. And if we continue simplifying this equation, we obtain finally V1 minus 2V2 minus 35 is equal to 0. By performing equation 3 minus 2 times equation 4, we derive one equation in terms of V1. Finally, we obtain V1 is equal to 210 over 7 is equal to 30 volt. And now, by performing equation 3 minus 9 times equation 4, we derive one equation in terms of V2. That means finally V2 is equal to negative 35 over 14 is equal to negative 2.5 volt. After completing the calculations, we conduct a simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. We can see here is the independent current source IA and the independent current source IB, resistor R1, R2, R3. We connect here voltmeter in order to measure the node voltage V1, and here another voltmeter to measure the node voltage V2. If we go to analysis, they say analysis calculate nodal voltages. We can see here that V1 is equal to 30 volt and V2 is equal to negative 2.5 volt. Upon completing the circuit simulation, we can clearly observe the similarity between the simulation and calculation results. This serves as a validation or verification of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to share and subscribe. Take care and bye bye.